Hello everyone! Today we're wrapping up the ISO tutorial series. We'll do so by adding a bit of UI polish, and then I'll give some pointers in how you could go and improve this project further. So let's get started. The first thing I want to implement is zooming in and out of the map. So to do that, let's go to our content view and let's go to where we have our rotate buttons. Let's add some buttons here to do zooming in and out. And we'll use a zoom out, but also I'm going to add an image called minus magnifying glass. And this one uses an image in the SF symbols catalog. So if you never use this program, this one contains a lot of standard icons that are available within iOS and macOS. And for instance, this one, the magnifying glass, should be here as well. So we have one with a minus and a plus, and these are the ones we're going to use. Okay, so that will show us a nice image. Of course, we also need it to do something. So let's say if we do this, we call zoom out on our scene. This one we need to implement. I'm going to quickly create two stubs. We'll implement them in a bit, but just so this one can compile. And we'll do something similar for zoom in, but this time it'll be a plus magnifying glass. And also we're going to style the buttons a bit. So I'll make the fonts, I'll make them pretty large, and I'll use the icon only style and add some padding. And the same for the other one as well. Also, we can use the same thing to style these rotate buttons a bit nicer. So let's do that as well by adding a system image called arrow counterclockwise and an arrow called clockwise. And if we build and run this, we should have a couple of new buttons on the screen, as well as replace these text buttons by actual icons. So let's see how that looks. Okay, so we have our rotate buttons, those fortunately still work, and we have our zoom buttons, those don't do anything yet, but this is what we'll implement now. To do zooming in, we're going to use our game scene, and we're going to set a couple of zoom levels that we support. So let's say we have the zoom levels that we understand are 1.0, 0.5 and 0.25. A zoom level of 1 is what we currently have, 1 to 1. 0.5 makes everything twice as large, and 0.25 makes everything 4 times as large. Also, we're already starting at the 0.5 scale. That's another problem. Then let's choose which zoom level to start in. We'll create a zoom level index variable that holds the index where in this array we are. We started 1, so we started zoom level 0.5. That's a nice medium zoom. And then we need to make sure that we implement our zoom in and zoom out. Zooming in means that our zoom level index will be the minimum of the zoom level index minus 1, plus 1, or the zoom levels dot count. So we can't go above the biggest of the last zoom level. So our zoom level is self.zoomLevels zoom level index, and our camera set scale can then be set to our zoom level. This part we can copy paste for the other one as well. However, our zoom level index will now be the maximum of our zoom level index minus 1 and 0. So we clamp the value between 0 and the number of entries in the zoom levels array. So let's see if this works. It isn't working as expected. So let's see what we're doing wrong. Oh, we can't use the last one. Let's see if this helps. So, but this is still not working. Let's go into our content view, and well, it would help if we would call the correct functions. So we zoom in, we zoom out, and as a maximum we can zoom in and out. But now we can zoom in this far, we can no longer see the entire map. So I think we should start working on panning as well. Panning is actually pretty simple. We go into our game scene and we calculate our camera screen position here to a hard-coded value. What if we take out this hard-coded value and instead use the view models selected tile, and if that one doesn't exist, we can use the existing one as a default, and I think that should be enough to also have panning around. Okay, so we have two parts done already. There is something interesting happening if you rotate around a bit. Let's see if we can explain it. When you rotate or use the buttons, you click both the button as well as a tile that's underneath can be triggered because the game scene is reacting to these clicks as well. What I would like to do is, if you click one of the UI elements, you wouldn't want to also change your selected tile or your selected unit or anything like that. And that requires a bit more work. We can do that by slightly refactoring the way that we call the touches began function, and by doing a bit of a trick or a hack, and that is by inserting a more or less transparent a view between the sprite view and the VStack, and let's give it an opacity of very little, but it still needs to be there, and then we can add an untap gesture, and where we get our screen coordinate in, And then we can do scene process tab. This is a function we'll just implement at the screen coordinates. This way we are more or less bypassing the direct. This way we can bypass the touches began function and only trigger this one. This one only gets triggered if no other UI element is clicked on. So instead of calling this one touches began, what we can do is we can create a function called process tab at a screen point or screen coordinate. This will be a CG point. And then we can get rid of this code, and the scene point can also go. We just do the node coordinates at the screen coordinates, and then oh, I'm sorry, what we need to do is we need to convert the screen coordinate to a scene point, and now the rest of the code should stay the same. So if you build and run, you shouldn't really notice too much difference. You can still click around and zoom in and out. You can still rotate, but now you can't accidentally change the selected tile by rotating around. So I think that's an improvement. Okay, so that's another one of the things I wanted to solve done. What I also want to prevent, and this will be the final real change to the program, is prevent if, let's say, an animation is playing. Let's use an animation here. I can still click stuff and strange stuffs happen. So let's try again. Let's move. Again, and I can rotate, and then animations get replayed and replayed and replayed. So that's not what I want. What I want to prevent is I don't want the UI to be really accessible if something is playing. And to do that, I'm going to add something to our view model. I'm going to check if the view model is busy, and if it's busy, I'm going to disable the UI elements. To do that, we need some tests in our view model. They can go above these combined tests, and we'll say create a test called click tile. Is busy when any action is being performed. And we'll create an entity. Add some position, and we'll create another one. We'll create a view model. In our example map with these entities. Let's make sure that entity 1 has a current action. And then we will assert that view model is busy is true. Which means we need to implement the isBusy variable. So let's go into our view model and create a variable called isBusy that returns true. Okay, so we can build and run tests. Okay, so the test succeeds. That's cool. But what if no current action is playing? So click tile is not busy when no action is being performed. So again we have our two entities, but again we have our view model. But this time we're not going to give any of them a current action, and now we can assert that is busy is false. Run tests. Of course this test now fails because we have hard-coded value here. So we need to do this, needs a bit more logic. Let's take our entities, compact map them, and let's say that current action is empty equals false. So if it's not empty, then it's busy. And now the test pass. Let's see if we can use this in our content view. We add all the way at the end, just before our ignore safe area, we can add disabled view model is busy. Let's run. And let's move this unit, and now we can't click anything until it's done, and now we have UI response again. I guess this is a pretty crude way of doing it, but I think it's good enough. There's just one more thing I want to solve. Sorry about that. Let's say we kill our knight. So this will take a bit. And I think one final blow. We can still click the knight. It's still sort of visible here. What I think we need is our view model to ignore defeated enemies. So let's create a test for that. Click tile. Ignores defeated entities. Let's get this stuff again. But this time we said, well, we only need one actually, I guess. So let's keep the test as simple as possible. Our entity.current HP will set to 0. Then we'll do view model click tile at entity.position. And then we assert that our view model's selected entity is nil. Let's see, this one doesn't exist. So let's run tests. They fail, but if we in our click tile add here, if we're checking to find an entity at a position, if we also check that entity is active, then now the test should pass. And also if we do our manual test, so it's a bit tedious, but okay, let's attack. Let's attack. Let's attack. And once more. So the knight is now gone, and now we can no longer see the defeated version here. So the view doesn't pop up, as well as on the bottom it no longer says the selected entity knight. So for this is all the polish I want to do for now. Let's say you now have this project and you want to go further. What could you do? Well, the first thing I would probably add is AI for the enemies, so it becomes much more of a game or a challenge. I'm not doing it in this series primarily because I don't think I'm good enough at AI development to really have you learn something. I'm a bit concerned that I would just learn you all sorts of stuff that's actually a very bad idea in practice. So I'm taking that one perhaps somewhere in the future, but I don't think I'm the one to teach you how to do AI. What you could also do is change a map, create a bigger or a nicer map. I think that could be an interesting course of action, of course. And you can create additional units. So our entities are still pretty plain, but you can do with differencing how much height you can traverse, how much range they have, how much attack range they have, what kind of... you can already do a lot by changing the sprites around. You could create a maximum HP and differ the HP per type of unit. And you might want to use... We have a hard-coded damage value currently for attack actions. You might make that something a part of the entity that determines how much damage they do. Or you could use something like equipment and make it more or less calculated or variable. There's just a lot of stuff you can do there. What I would probably also do is the entity is starting to accumulate a lot of properties. And most likely more and more will be added, because you can also take a look at magic points. If you implement some magic system and perhaps other types of points, you might add statistics like attack, defense, intelligence, stuff like that. I would probably, this is the moment I would definitely start refactoring this and use components as we did in one of the previous series, just to make it to prevent the entity becoming so large with so many data that you get that it becomes difficult to manage. And it would also help provide some more flexibility, because you could have entities that don't have any attacks or don't have any magic or can't move, are so to say immobile. So there's a lot of stuff you can do if you start transforming these into components and have the entity be more or less a collection of components. But I'm going to stop it here. If you made it all to the end of this series, thank you very much. It's an honor always to make these, and I'm looking forward to seeing you again in the next series. Thanks for watching and have a great day.